So go ahead and define the very first word you see on the note guide, which is a triangle. And notice the definition of a triangle. Notice the definition of a triangle. It involves our basic structures from last week. Look, it's got the word segments. It's got the word non-collinear. It's got the word points. It has all the basic structures. Remember the basic Lego blocks that make up everything else? Well, notice how it's involved in the definition of a triangle. I know what a triangle is. You know what a triangle is. But now look at the formal geometric definition now. The geometric definition involves the basic structures we learned about last week, and which we took a quiz on Friday, which I'll have the results back by today. So notice that. Copy that down. The vertex. Each of the 3 points joining the sides of a triangle is a vertex. Remember that one down.
Or would you like me to put this?
Each of the 3 points joining the sides of a triangle is a vertex. Next to vertex, go ahead and draw a triangle with me. And let's highlight the vertex of a triangle. So right here, you're going to draw a triangle. You know what a triangle is. Let's label each corner P, Q, and R. Now, a vertex is just the corners. You already know the term vertex in the context of angles. But vertex in the context of triangles are just the angles themselves. It's just the corners. So you can put a little arrow here at each vertex. So that's what I'm talking about when I talk about a vertex. So there's 3 vertexes, but the way to say it plural is vertices. Each one's a vertex. The corners of a triangle is a vertex. You got P as a vertex, Q as a vertex, R as a vertex. Go ahead and put that on your picture. Next word is adjacent sides. Adjacent sides. In a triangle, 2 sides sharing a common vertex are adjacent sides. This will be the 3rd word. Phone's away right now. Earphones off. Adjacent sides. So, off to the side on this definition, I'm going to draw adjacent sides. Watch. Do it with me. Let me draw another triangle. I'll label the vertices this time A, B, and C. Do that with me. Now, what are 2 sides of this triangle that share a common vertex? Can someone name me 2 sides that share a common vertex? So side BC, notice it's a segment, and what other side? AC. Notice that. Notice how those 2 sides share a common vertex, namely C. So those 2 sides we would call adjacent sides. You know what adjacent angles are? They're angles next to each other. Here on a triangle, they're just 2 sides that are next to each other that share a common vertex. The definitions are a little different, but you can see the commonality between adjacent angles versus adjacent sides. Remember, they just mean right next to each other. All right, next word. Here we go. Next word is legs. Yeah, this was the longest one. Go write the word legs. In a right triangle, the sides that form the right angle are the legs of the right triangle. In an isosceles triangle, the 2 congruent sides are the legs of the isosceles triangle. Let me copy that down. So let's draw this situation here. Notice In this definition, it mentions a right triangle. Notice. The first sentence here of this definition mentions a right triangle. And the second sentence mentions an isosceles. It's kind of spelled like you would pronounce it isosceles, but it's, the way you say it is isosceles. Isosceles. So two kinds of triangles are mentioned here that I haven't gone over. You guys may have seen this maybe in pre-algebra or some previous math class. I want to talk about these two types of triangles really quick before I get into the definition of them. It's pretty basic to watch. I'm going to move this. Let's draw a picture of the situation. Now, let me just show, before you draw anything, let me just show you something here. Let me create some shapes here. I got some triangles. Notice what I do. When I touch my smartboard, it just creates triangles. Okay. It's actually a triangle, you just can't see it. My point is here is that, look, triangles come in infinite various shapes and sizes. Right? All shapes. These are all triangles. They're all three-sided, three angles inside. Various shapes and sizes. But there are certain kinds that are called right triangles. It's a very special kind of triangle. It's called a right triangle, and a very special kind that's called an isosceles. Let me erase these. Does anybody remember what a right triangle is? Hit it. What is a right triangle? Nice. So it's a triangle that has a 90-degree angle in it, which is called a right angle. So on your notes, let's draw a right triangle. Do that with me. Here we go. So a right triangle is one of these. Check it out. I'm going to draw a triangle. But I'm going to make sure this angle right here is 90 degrees. Remember the video you watched last week? That box means 90 degrees. Go ahead and draw that. That, ladies and gentlemen, is a right triangle. Not all triangles are right triangles, only ones with right angles in them. A very special kind of triangle. And notice what it says about the legs. Look at the legs of a right triangle. It says, in a right triangle, the sides, what does it say? Can someone read it for me? The first sentence only? So the sides that form the right angle are the legs. In other words, this side, up there, this side right here and this side form the right angle. So these two sides here are the legs. You might want to just go and put an arrow here and an arrow here to point at the two legs, because those are the sides that form the right angle. So that's the legs of a right triangle. But now, a different kind of triangle is mentioned in the second sentence of legs, an isosceles triangle. So let's do that one. Does anybody besides Ochoa remember what an isosceles triangle is? Hit it, Cruz. Right, so it's a triangle with two sides being congruent. Perfectly said. Watch this. I'm going to draw a triangle where two of the sides are the same measure, congruent. So this side right here and this side are the exact same measure. And the way I communicate that on the picture is I just put two hash marks here, or one hash mark. In any geometric book or literature, whenever you see these little hash marks, that's communicating that those sides are the same measure, the same size. So the legs of an isosceles triangle, right triangle, isosceles, the legs of an isosceles triangle are the two sides that are congruent, this side and that side. Okay? That's what legs mean. You have legs of an isosceles versus the legs of a right triangle. You got to know the both difference between both. Hypotenuse is the next word. It's a Greek word. Hypotenuse. The side opposite the right angle is the hypotenuse of the triangle. Go ahead. The side opposite the right angle. That's okay to say that. the side opposite the right angle is the hypotenuse of the triangle. So what I want you to do is draw an arrow from hypotenuse up to the previous right triangle that we drew. Put an arrow going up, and it's this third side. Notice how this third side right here is opposite the right angle. Okay? So draw a line from hypotenuse up to the previous picture of a right triangle. I'm bringing the arrow up. And it's this side is the hypotenuse. The other two sides are called the legs. We just reviewed that. This third side that's opposite, look how it's opposite the 90-degree angle. It's on the opposite side of the triangle. In other words, it's not touching the right angle. This side is always the longest side. It's always called the hypotenuse. All right? So we've got hypotenuse and then last word for the day. Actually, two more. We're not gonna finish it all today. Next one is base. Second to last one. Leave me alone. In an isosceles triangle with two congruent sides, the third side is the base. In an isosceles triangle with two congruent sides, the third side is the base. That's pretty straightforward. Side. So what I'm going to do on this one, right, just draw a line from the base up to that isosceles triangle we drew. This would be your base. Shh, man. Here you go. So just straight to the base. Interior angles. When the sides of a triangle are extended, the interior angles are the three original angles. We're just going to fill in the blank on one thing right after this. Not a word. It's not a word. It's a fill in the blank. When the sides of a triangle are extended, the interior angles are the three original angles. Let's draw some interior angles. So I'm going to draw a triangle. But on this specific triangle that I'm drawing, I'm going to extend each side. Watch this. I'm going to extend this side. I'm going to extend that side. Extend this side. Extend that side. Do that with me. Tomorrow we'll talk about these angles that are formed when I extend them tomorrow. But for now, the three original angles that are inside these angles, look at the three, are called the interior angles. Okay? So we call them the interior angles. And there's a special law of mathematics that we're going to explore right now regarding those. This is called a triangle sum theorem. Now, sum means to add stuff up, right? So it just, you add up the interior angles of any triangle, they're going to equal 180. Now, off to the side. We don't have to check it, but we're going to prove right now. Watch. Watch this. I want to talk about what the word theorem means. What does this word theorem mean? Off to the side. Just write down, we're going to write down a quick definition of a theorem because it's the first time you've seen it this year. A theorem, ready? This is the last thing we'll write down here. It's a law of mathematics. A law of mathematics that has proven to be true. A law of mathematics that has proven to be true. That's what theorem means. You're going to hear the word theorem come up for the rest of the quarter. We're going to explore some more theorems. But it's just a law that's always true. It's always the case. Okay?